Okay, we have this problem where we have a uniform bar with mass M, and we have it pivot at point O, where it is in the uh, um, roughly not exactly in the middle, but it's at the location of L over 4, pivoted at point O in this case. And we have the K, okay, we have two Ks here, all are linear springs, and also we have C. So let us take a look, how do we actually draw the free body diagram. So you can see that there is no assumed direction in the question, so you need to start off the first part of it with the assumed direction. So number 1, so if you don't have it in the question, you have to assume. So let's say I assume the counterclockwise to be the direction, a positive direction. And notice that in this problem, you do have input to the system, and you have the x naught here, x naught sine omega t. Okay, so we have to ensure that this k here is in between the displacement at this point Q, at point Q, and the other point P here, which is X. So since it is in between these two position of the bar, okay, at point Q and also point P here, then you need to do, there is a relative displacement that you have to consider. Means you have to determine which one gets negative. Okay, all right. So just take note of that. So first of all, since we assume that it is counterclockwise, so maybe I can just draw what happens to the bar in this case. So the bar will look like this, and at point O there. And you have to think what happened to the K, the C, okay, when you actually have this bar going up. So basically you have to think of the physical movement of the K. So basically, if I can imagine, so you have to draw on the K first. So the K will go down because this side go down. And the C, so the C is somewhere here. Maybe I make it a little bit somewhat about the same distance. Okay, let me just draw that a little bit more. So let me start with over here, and then you have your K here, so it's easy for you to see. So K going down because this side is going down, this side of O, and this side all goes up. So your C will actually eventually goes up. So you can draw your thing goes up. Sorry, maybe that is not the correct way to draw it. I pull it up a little bit. Okay, let me just okay, then only you have the arrow going up. Okay, and you also draw here. So in this case, as I said, your K, so your K is over here. So you have to, if you remember, in order to determine the relative displacement, you have to assume whether it's in tension or in compression. So if I say, I assume that this will go like this, okay, regardless of this position, it's supposed to go up, but because you have relative displacement, I have to assume tension. So when you actually assume tension, you know this side will go downwards and that side will go upwards. Okay, so then I draw, then I have to determine the direction of this relative to the x here. Okay, this side is for x. Okay, let me just change maybe the color a little bit. So you can see that if you look at this side, it has to follow x direction. Okay, then you have this side to follow this direction, the movement of the bar. So if you look at here, it's opposite, right? Because your x going up is positive. Okay, let me just cancel that. Okay, so okay, this thing is moving. Let me just get it back. Okay, so when we have that, then we can write here. So basically this one is you're gonna get negative x. Okay, which is the whole thing, yeah, negative xt, because it's opposite direction. All right, so this one, sorry, this is supposed to be positive, and this one, okay, then we can actually draw the action reaction. So that goes down, this one goes up, that goes up, this one goes down, and that goes down, this one goes up. Okay, so when you actually goes up as positive, so you have this one is negative. Negative. So what do you write as that? So you can see that this distance here to here is actually L. Okay, however your pivot point is here, so this distance to this distance is actually what, 3L over 4. Alright, so how do you write that? Basically, so that K, this is supposed to be Kx, okay, but your X you have to write in terms of relative displacement. So you have to write as K, supposed to be X, but it's actually 3L over 4. If you remember the concept in terms of small triangle, okay, where you actually have your here is 3L over 4, and then you actually have your theta, so your x is equals to 3L over 4 theta. Okay, I hope you remember that. Then you have to minus, so this one is supposed to be x minus. Okay, it's supposed to be x minus. Let's see. So that will be x minus 3L over 4 theta. Okay, then this one is easy. So this distance here is L over 4. So you will just have K L over 4 theta. And here you have C L over 4 theta dot. Alright, so when you actually write your equation of motion, then you would have J theta double dot equals to summation of moments. So which direction you look at? As I said, we already assume counterclockwise as positive. So you look at this, if you go from pivot point to that arrowhead, you will get negative. Okay. So you will have your negative. So you have your negative KL over 4. Don't forget, this is more of force. So you have to times L over 4. And then you have this one as a positive CL over 4. It's not positive, it's negative CL over 4 theta dot times L over 4. And then you have your K is positive here, so you have your positive K, you have your XT minus 3L over 4 theta. So don't forget as well, I haven't substitute this XT into X0 yet, so don't worry, we'll do that later. But this one, you need to make sure that you times 3L over 4. Okay, so then when you actually rearrange the equation, so what you get is J theta double dot, and you bring everything to the other side except for the input to the system. So this one, if you what you need to do is you collect all the terms, like all the theta dots. So here you can see, okay, all the theta dots together. So you can collect all these terms, and then you have your theta terms together, and you leave your xt term on the other side of the equation. So you have let me write that down. Then you should have, if you do that, here you have negative, then you bring to the other side, you get positive L. So this will have L square, yeah? So you have 1 over 16 CL square theta dot. Okay, then you have to plus your KL. So if you do that, see you have this term here, which is negative will become positive, both of them. So you have 3L and L, and you can don't forget to times this term, yeah, over here. So kind of a bit confusing there, but if you do that, you should get a 5 over 8 KL square. Okay, and it is equals to, so leave the xt term because it's input to the system, so it's equals to just 3 over 4 KL xt. Okay, so that KL xt, so then only you can substitute as well in terms of sine function, 3 over 4 KL sine x naught sine omega t. Okay, so let me write that in full. So all this is actually J naught. J naught means the moment of inertia about the pivot point O. Okay, so 1 over 16 CL square theta dot plus 5 over L KL square equals to. Alright, so basically that's the equation. So hopefully you can actually derive and understand how to get the equation. Alright, so that's all. After that, you look at all the given values and substitute into the equation and use the standard equation to get the response of this system. Okay, so that's the overall how you would derive the equation of motion.